Swayam Prabha. Digital India. Educated India.
So, this is the second lecture on the introduction of the civil engineering profession. In the first lecture, we had discussed what civil engineering is all about, what civil engineers are expected to do. And this lecture, we are going to look at what are the different specializations within civil engineering and what they cover and what the scope would be in each of these cases. So, these are the different civil engineering specializations that you see here, starting from say the environment and looking at environmental engineering, how we interact with the environment, how should we take care of the environment. The soil, the ground, geotechnical engineering covers that. Hydraulics and water resources deal with the flow of water and how we can control, save and utilize water better. Construction materials and technology would look at what is used in construction, what are the technologies available and how do we efficiently have construction going on. Structural engineering deals with the design, analysis of structures that we want to construct. Transportation engineering, as the name implies, deals with the planning, design and construction of all transportation facilities, mainly roads, railways, ports, airports and so on. Construction management is a very broad discipline which takes care of the managing, using resources efficiently in whatever civil engineering project we take up. Finally, we have urban planning. Sometimes it probably comes first before anything else starts, to look at where cities should come up, how they should develop and even projecting how they will develop in future. We will start with environmental engineering. Environmental engineering deals with providing water that is drinkable to people, taking care of wastewater, treating it so that when it goes back into an environment, it does not harm the environment. So, at the top you see a picture of a wastewater treatment plant, where there is water that is coming from sewage of households and industry, treated such that it can be put back into the environment. In each case, I am giving here the reference where this image was taken, and that could also be a reference for getting more information regarding these aspects of the different topics that I am talking about. Waste management is a very important area, as it is obvious human beings consume a lot of material and also produce a lot of waste. All this waste has to go somewhere, properly treated and hopefully recycled, brought back into the system. So, we have to analyze what are the wastes that are being generated, quantities, types, collect it properly. Now, we are starting to segregate more and more. In most places, the waste is segregated at source, and then we can decide what to do with the different types of waste. So, it has to be transported, and as much as possible we would like to recover whatever we can from waste. Glass, for example, is something that is readily recycled, then you have plastics and many other things. And maybe some of the other material, which is biomass, can also be used in some way as fuel or in some other purpose to create energy, so that it is just not dumped. So, as much as possible, see if we can recycle, reuse some of the material which is coming in waste, and only finally, if we cannot do anything with it, see how to dispose and where to dispose. Another aspect of environmental engineering is pollution monitoring and mitigation. As urban environment comes up, as cities come up, we pollute air, we pollute water, we pollute groundwater. So, monitoring of this and mitigation is very important, because just knowing that this is happening is not enough. We have to see how to stop it and how to make sure that the pollution does not keep on increasing. Otherwise, our cities are going to get dirtier, the air that we breathe in is going to become more difficult to breathe, and our groundwater will become contaminated, and it will spread to the environment all around these cities as well. So, environmental engineering does all this, aiming to protect and improve the natural environment, where we all have to cohabit and work and live. It draws upon basic sciences like chemistry, biology, fluid mechanics, because these are sciences that are required for designing, operating the systems that have to be built, for providing drinking water and for treating waste, municipal as well as industrial waste. Depending on where the waste comes from, the treatment may be different. We have to see what are the contaminants and how they can be treated or handled before the treated waste is sent back into the environment. This also brings up the very importance of a civil engineer knowing chemistry well. Lot of environmental engineering processes draw on chemistry and the understanding of chemistry as much as we are concerned. The other aspect is monitoring and modeling of the environment. There are many processes that we have to say how they will evolve over time. So, modeling is very, very important. We have to understand the phenomena and see how they will affect the world in future. How much will temperature increase? How much will the carbon dioxide in the air increase? And if so, how are we going to stop it? How are we going to limit it? And how are we going to mitigate it? How do these pollutants move? See, pollution in a city does not stay just in the air of the city. It can move, it can affect neighborhoods, and sometimes we have large movements of contamination. In Europe, when there was the Chernobyl accident, the radioactive crowd moved towards large parts of Europe and affected areas that were very, very distant from where the accident occurred. So, we have to understand how these pollutants will move and where will they reach. And as I said, the different areas that we have to understand is chemistry. There are reactions, effects of these reactions have to be understood. Biology, because we are dealing with not only human beings, but many other living things that are on the earth along with us. Mathematics is needed for the modeling. We need sophisticated models sometimes, which depend on many aspects as they could be in the environment, to tell us how the pollutants will change, pollutants will spread, and how pollution will change, increase, for example. And that will lead us to design, for example, of design of wastewater treatment plants. For that, we will have to know where it is going to be situated, what waste is coming in, how the population which is producing this waste is going to change with time, and therefore see what would be the adequate design for the wastewater treatment. I have already talked about pollution and its mitigation, and finally, an important aspect of design of almost everything that is large is the environmental impact assessment. When we have a large project, say a new township coming up, or a dam coming up, or a canal, now it is almost necessary to have what is called an environmental impact assessment. How is this going to affect the environment in general? What are going to be the emissions? What are the resources that are going to be needed? And how will this change the environment where this is coming up? Okay. So, this is again something that environmental engineers do. Moving on, geotechnical engineering, as the name implies, is whatever that has to do with the earth, the soil, the ground. So, suppose we have to make a tunnel. For example, I have the image here of the Chenani Nashri tunnel in Jammu and Kashmir, where you have a large tunnel network being built. These tunnels have to go through a mountain, go through rock, go through soil. We have to understand the soil. we have to understand the rock, we have to see how to make this tunnel safe when you are drilling, boring, and also during the life it has to be safe enough and it will withstand the pressure of the earth around it and the movements and so on. Whenever we have a large building, a high-rise building, you need a strong foundation, because everything that you see above the ground is transferring the load into the ground. So you have to make sure that that is going to be stable. So we have to understand how to make a foundation of these structures so that they will last a long time and keep the building safe. Also we have to understand that the earth itself can move, the ground can move when there is an earthquake, when there is settlement, the ground can move. So we want to make sure that it stays stable. So there are techniques where you can strengthen the ground. So there are ground strengthening techniques. If the ground is not strong enough for what you are going to put on top of it, can we strengthen the ground? You may not have a choice to say that I cannot build here, I can move elsewhere. So we have to see how to make the ground strong enough for whatever we are constructing on top or within it. So geotechnical engineers understand earth materials, whatever is in the ground, and see how to design safe foundations for structures that we are going to place on them or within them. So they analyze the behavior of soil and rock so that they can design these structures safely. The structures could be high-rise buildings, could be pavements, underground facilities. We talked about tunnels. In India, almost all the major cities are having metro tunnels. And surely we will have these projects running for several decades in India and other parts of the world. So these are structures which are mostly or at least partially under the ground. And we have to make sure that the drilling process, the excavation is done safely, economically, and the structure once it's constructed is safe enough for transportation to occur through it. So underground structures are becoming more and more important. We also need underground structures for containment of waste. Suppose we have radioactive waste, we have to store it safely. We cannot have leakages, we cannot afford to have this waste escape into the environment. So we need containment vessels, we need containment structures that will keep contaminated waste or waste that could contaminate in a protected place. I have already talked about foundations. So foundations are the substructure which holds the structure, superstructure that we see above the ground. Retaining walls are those that prevent soil from moving. Say if you have a slope, you have an excavation, you don't want collapse of the soil to occur. So there we have retaining walls. Tunnels I have already discussed. So anything that is on the ground, under the ground, needs geotechnical engineers to study the situation and tell us how to go about it. And for this, the geotechnical engineer has to understand mathematics well, because there is a lot of modeling of the response required. Physics, of course, they have to understand soil mechanics, how the soil will deform, move, shift. There are a lot of theories which tell us how the soil will behave, how rock will behave, and how will they fail. We also need to know how failure will occur, so that we can prevent it and we can design for loads that will not cause failure. Foundation design, as already discussed, is very much required for any type of structure now, because the ground has to withstand the loads, should not deform too much, and it should be safe enough for the structure to sit on it. Slope stability is very important, because we have areas where you have to cut through mountains, hilly areas, and when you make a cut, you leave a slope that could become unstable and collapse. And we certainly don't want that to happen. So we have to understand how to cut a slope so that it does not collapse, and if it has a potential for collapse, what should we do to maintain the stability of a slope. Seismic engineering is everything to do with earthquakes. Earthquakes, as we all know, involves the shaking of the earth. It can be vertical, horizontal and combination. So, if you have a structure sitting on the earth and the earth is moving, the structure could fail, the soil could become loose, liquefy, settle, crack and so on. So, we have to anticipate what could happen in a certain region. With more and more knowledge in seismic engineering, we are designing better our structures for such type of actions that come from earthquakes. I have already talked about underground structures. The best example that is closest to most of us is metros. We use subways and we want them to be safe, because we cannot make transportation within a city without metros nowadays. So, everywhere we have metro construction happening and we want to understand the best way to construct and keep these structures safe. Another aspect which deals with the ground is how water flows on the ground, hydraulics and water resource engineering. So, there are large structures like dams that have been built over the course of history. We still build large projects which involve dams, where water is stored for irrigation, drinking water purposes and also to generate electricity. It is one of the cleanest ways to generate electricity. So, we have several large projects which are hydroelectric projects which provide this pressure due to the buildup of water that can be used to generate electricity. These are all massive projects because they involve making a huge reservoir that can collect the water, and the impact on the environment, on people is tremendous. So, they have to be done properly and safely. This water is often transferred to the places that we require them. This is an example of a canal in Rajasthan, where a desert land can be converted to a livable place where you can have irrigation by having proper canals. So, this will require us to understand where to store the water and how to move the water. The water has to flow by gravity, so we have to understand how to make it flow in the direction that we want to, and it should reach the place that we want. And sometimes disasters happen, say in floods. This is an image from a recent Chennai flood, and we find that sometimes there is too much rain, there is too much of flow of rainwater, and that could flood unintentionally, obviously, a city that is inhabited by a lot of people. So, here again our hydraulics engineers will have to estimate when this could happen using statistics, using the knowledge of historical data. They have to guess what would be the maximum rainfall that is reasonable to use in design, and if this rain falls, how is it going to be handled such that it does not become unsafe for the city, for the people and for the businesses in the city. So, there is a lot involved in storing and conveying water. On the other hand, also we are worried on protecting too much water from coming into the city and destroying the city and its people. So, the hydraulics and water resources engineers apply methods, analytical methods, computers, fluid mechanics to the study of flow of water and controlling this water, so that we use it when we need it and it is not going to harm us during its flow. So, flow and control is important, and we collect, like dams, as I said, is a way of collecting water. We can have tanks and we can have other facilities, and then supply this water where it is required, and this same can be extended to other liquids. There are civil engineers who work on the flow of blood in the body, because it is also a fluid. So, there are many fluids other than water where these principles of hydraulics can be used, and civil engineers also work on in these areas. They mainly do the design of hydraulic structures and machinery that is required for controlling water and moving water. They spend a lot of time studying rainfall, especially in a country like India, where we have a lot of areas where we do not have water readily available. So, we have to study when will we get rain, how much rain, and how are we going to store and use it properly. so that we can control its flow, decide the flow and collect it. Disasters happen and lot of it is because of storms and floods. And there are many hydraulics engineers who study storms, see how they move and even predict and warn people that there is a storm approaching, that there could be a flood. So that even though we have designed well, there could be something that is beyond our control. So we can warn people that a storm is coming, we have to evacuate, we have to be safe, we have to move to higher ground so that they are not affected by floods. So they base a lot of their work on mathematics, lot of analytical work is needed, physics obviously, fluid mechanics is a special area of mechanics of physics that deal with flow of water, flow of different fluids, pressures it creates during its flow. Hydrology is the study of flow of water on the earth and they end up designing a lot of water supply networks. Our cities are growing, new cities are coming up, we need to provide water. So the water supply networks also have to be designed properly and hydraulic structures like dams and canals. So these are the different areas that hydraulics engineers work on. Next we would come to the area of construction. Construction involves resources and materials and processes. So the people who are involved with construction materials have to decide what material to use, how much to use and how to use it. So here we have an image of a huge construction site and these green lines that you see here, each of them is a pump delivering concrete. So you have a bunch of them and then there are concrete trucks here, you see the concrete trucks here and this is now going to go into this huge construction site where probably the foundation of a very tall building or set of buildings is coming up. So construction materials expert has to know which concrete to use, how much should be delivered, how it should be delivered and the construction technologist has to see what are the equipment required so that this material will be delivered correctly and on time. We see here some cranes. So material has to be lifted during construction. How many cranes do we require? What is the type of crane required? Has to be decided by somebody who is going to tell us what type of technology is best suitable. Here actually you have a tower and as the tower is building up, the crane is going up by itself. So the crane is also sitting on this tower itself. You see here the crane is attached to the tower. So as the tower is growing, the crane sort of moves itself up. So it's always above the tower so that it can lift things and put on top of a tower. Concrete might seem a very mundane material. Everybody thinks that they know everything about concrete. But there are people like me, for example, who do a lot of research on concrete. And now the new thing which is the buzz is 3D printing. And if we 3D print everything, why not concrete? So this is an image of 3D printing of a wall with concrete. So you don't need to have a mold or a formwork. You can just pour concrete and it stands up. This is being done in polymers, it's being done with metals and many other materials. So the construction materials and technologist will look at what are the materials, resources required for the construction to be done properly and efficiently. So the engineer who works on construction materials and technology looks at the utilization of the material and equipment to implement the design. The design is given, now how best to implement it and make it happen. These could be structures or any other civil engineering project. They also have to take care of the maintenance. Structures become old, facilities become old. How do we make sure that they are in running condition and usable condition? When do we have to repair and how do we repair these structures? Design of new materials is very, very important. Just like our demands, our requirements keep changing, we have to supply, we have to come up with new materials. So these engineers will look at new materials, construction methods, how to improve the performance of the material. If we know that something is going wrong with certain type of material, how can we make that better? Quality of construction. We always hear a lot of complaints about construction not being good quality. So there are people who are supposed to work on that and make sure that this quality is improving. So they draw on the physics and chemistry to understand the behavior of materials. They understand what is there in the market, because you cannot in civil engineering use something that is very, very expensive, has to be brought from a long distance, because it makes the construction not feasible. Architecture, building physics is important. We want to design structures that are comfortable, that we should have enough ventilation, we should have enough lighting, and we should feel nice using the environment that is created for us. For these, drawings have to be made, and building drawing is something that is drawn upon at the construction site, where you put the ideas on paper, and this is what is taken to the site and used. Surveying is a science where you have to take measurements accurately of the land area and also keep track of what is coming up to see if it is of the right height, it is at the right location, and so on. So surveying uses principles and equipment which can tell us where something has to come up, where something is constructed, if it's right or wrong, and what is the elevation and height that it's at. Maintenance, as I said, is very important. All the facilities that civil engineers create, most of them at least, have to last for tens if not hundreds of years. So how to make sure that these are maintained well, that is also very important and has to have a scientific basis. Then we come to the structure. We have looked at the people who take care of the foundation, the people who have taken care of the material and the process. Now we have to design a structure like this high-rise building in Mumbai, or this bridge across the Yamuna river. This is a cable-stayed bridge where you have a deck over which the traffic is flowing, but the deck has to be kept across the river, and you have cables which are holding it up. These cables are tied to this huge tower which is above the bridge. You can have a steel bridge as well. This is a very elegant Howrah bridge in Kolkata, which shows the entire steel bridge and its skeleton or the structure of steel that is holding it up. So these are things which are very impressive. They could be tens of, if not hundreds of meters tall or long, and they have to be designed in a safe way and to last for a long time. So this is what the structural engineer does. The structural engineer analyzes the forces, stresses and deformations, and designs the structure so that it will resist the loads and any other action. The loads that are coming because of the people using, the weight of the materials, movements due to wind or seismic action, and still last for a long time. And when they last, we want to make sure it's functional. What do we mean by functional? It should be fit for use. If there is a bridge but the bridge has deflected a lot, or as the car is moving across it, it moves 1 meter. It may not break, but it is not functional. Similarly, if you sit in a building and for the least wind that you can have, it moves a lot, nobody is going to use the building. It may not fail, it will be safe, but it's not functional. Okay? So functionality is very important, and later on when you study more courses in civil engineering, you will hear this concept of serviceability, that it should be good for service, good for use. Obviously, all this has to be done within certain constraints of cost. It should look good, like the pictures I have showed you, show the elegance that can be brought out in a well-designed structure. And the social implications like ease of use, comfort, people should feel nice that of the structures that they live in and work in. Okay? So this again depends on the knowledge of mathematics to model the response of these structures. Physics very important for understanding the fundamentals for mechanics and the theories of failure and behavior. This leads on to structural analysis, which looks at deformations and stresses for given loads, and this is followed by structural design, where the concept is taken, the idea is taken, functionality is built in and translated to something that will go to construction for the construction manager to start executing. Transportation, as we all know, is very important. We use different modes of transport. Here we have some networks that I have shown. This is the expected national highway network of India, where several thousands of kilometers still have to be built to create this grid that connects different corners of India. Similar to roads providing modes of transport, waterways can also provide ways of transport. And now in India, we are looking more seriously as water, canals, waterways as mode of transportation, because we can transport goods very easily. This is done in many other countries, but in India now we have to work seriously on creating waterways where goods can be transported very cheaply without competing with the transport of people. This could be a mode that is dedicated to transport of goods. Other aspects of transport are also important. This is the Mumbai airport. More and more airports are coming up. Airports are coming up in remote areas, hilly areas, difficult to do construction in, but all this is important for providing the network for moving people, moving goods and keeping businesses and life going as we want them to. So the transportation engineer takes charge of planning, designing, managing of all the systems used for moving of people and goods. So they complete the cycle of taking care of planning, constructing, designing and managing. So they analyze the movement of people and goods, make projections for the future, because you know that population is increasing. We know cities are going to become denser. So how should our system also evolve? They design traffic management systems, and anyone in India would appreciate how complicated their life is to be able to design, plan something for an Indian city on how to manage traffic properly. So they again trust their mathematics skills for modeling the traffic flow. They have to understand physics and chemistry to understand the behavior of materials used, which material to use where. Should a pavement be of asphalt or should it be of cement concrete? So these are questions which come up and they have to understand the physics and chemistry. Their computational skills are very, very important. We have transportation engineers who are all the time looking at computational models to see how to predict how traffic will change and how it will evolve and how to manage it efficiently so that people don't waste time in transport. Social aspects are important. Will people use one mode of transport or not? When will people stop using bikes and when will they use a car? Will they use an auto rickshaw or will they go by bus? How can we make them go more to mass transport, public transport instead of using their own car? So these are sociological aspects that they have to study, and management principles, because a lot of these projects are huge. You have to manage money, you have to plan properly and see what is the policy and priority for the construction of such systems. Construction management puts all this together. Here we have some charts. So this is what is called a Gantt chart, where different processes or stages of construction are given here, and this is the timeline. So projects can run for several months if not years, and we have to know how to plan for the resources, the money and the time. There are new modes of construction management. For example, what is called public-private partnership, where if you have a public facility, not all the money is coming from the government alone. So the government is partnering with a private group. The private group is also putting some money, charging the users, and that way they are financing the project. Okay? So these are called PPP, or public-private partnerships. You must have seen many cases. You have highways which have a toll booth. So they collect money from you for using the road. That money is paying back what money went into the construction. And possibly once they have collected all the money, then it becomes free for the other users. So there are several models, but which again construction managers look into and decide which is the best model to use and how to manage such projects. Contracts are very important. A contract is an agreement between the different parties in a construction project, between the owner, the contractor, and the bodies that are administering. So there is an agreement saying that for so much money given, they will do the work in a certain way, comply with the rules and comply with the specifications. So how to write contracts, how to deal with contracts that go wrong. There will always be problems, there will always be something that went wrong. How do you deal with it? So these are things that the construction manager does. They plan, coordinate and control all civil engineering projects. They look at equipment requirement also. They design formwork. Formwork is where you pour concrete in so that it takes the shape that you want in the structure. Scaffolding is all the supporting part. Like if you have gone to a construction site, you will see that there are a lot of poles which are holding up some wooden elements where the concrete is going to be poured and will keep the concrete in place until it becomes strong enough. So scaffolding is anything that supports something and also can support people who are working at a construction site. All other construction equipment, we talked about cranes, there could be excavators. So lot of equipment are now required in a construction site. Robotics are becoming very important. You can automate, you don't have to need people all the time to construct. You can have sophisticated equipment that can be controlled remotely, controlled by few people and not to have many laborers at the construction site. Very importantly, a good construction manager should be able to manage time, money, other resources and deliver a construction site without delay and safety issues. They should make sure it's a safe site. So they have to be able to manage all this. Labor requirement, money and time, deliver good quality without safety problems. So again, modeling is very important, maths is important. Finance comes in. They have to be good at managing money and time as well. So they have to estimate resources required, money required. They have to understand management, management of people, management of processes and management of money. Sociology again, they deal with people. Quality and safety assurance is very, very important. We don't want a construction site to be dangerous. We want to make sure that the laborers are safe and they don't get hurt or hurt anybody else. I mentioned contracts. Contracts are legal agreements which have to be written well. So sometimes we find that in a construction project, the project runs into problems and when the contract is looked at, it has not been written well. Who has to do what is not clear. If somebody does not do something, what will happen is not clear. What is the compensation if there is a delay? If you finish in advance, will you get some incentive? So all these are taken care of in contracts. And a risk has to be assessed. Suppose there is an exceptionally heavy rainfall, will the project get delayed? And if so, what do we do? If there is a strike, what do we do? So there are many risks associated with construction management, which again a construction manager has to take into account. The last specialization I want to talk about is urban planning. So urban planners decide sort of how a city will grow. So they coordinate how a built environment will develop, how new cities will develop, how cities will transform with time. So they look at road networks, where green areas should be, where should we have parks, recreation areas, where should be and how should be the combination of residential, commercial and industrial spaces. Here I hope you recognize this as the IIT Madras campus. So we have the entrance here and we have a green area all around. Right? We have a green area running here which has been set aside for animals and for greenery. Then we have a residential area, then we have an academic area and a student area. So this is how the master plan was done in the 1960s. And the growth of the campus has sort of followed this. So this gives the main arteries. So you have a roads running through the campus, and there is a place where the hostel sector has grown. Instead of randomly putting one hostel here, here and here, there is a certain plan, there is a certain concept that student facilities should be grouped together so that students can approach easily. Students should be able to reach the academic zone easily, otherwise they'll be late for class. Sometimes even putting it close, they'll be late for class, but at least we try to put them as close together. They don't have to cross from one end to the campus to the other. The people who are here with families, they are put close to the gate so that they can go to the children's schools, they can go out without having to cross the whole campus. So there are plans, there are concepts, there are needs why these things are done. So these are based on architecture, transportation, services, where to put the substation for electricity, where to put the sewage treatment plant, where to put these water tanks that we have in different parts of the campus. Balance between how much should be the open space and how much should be built space. How would this campus grow? So when this campus started, we would have had few hundred students. This became a few thousands, even as recently as about 10 years back. Now we are getting ready for 12,000 students, but the space is the same. So we need a plan to understand how a campus or a township will grow and how to make it grow properly instead of randomly. So these are the different specializations of civil engineering, and it gives you a flavor of all the different aspects we need. Also very importantly, I have tried to highlight what do you have to know to become a specialist. Why we have to understand maths, physics, chemistry, biology and other sciences, because they form the basis for what we are going to do later. If you have to analyze, you have to know certain things before you do it. So that is why you start off with revision of basics, strengthening the basics in many aspects before you go deeply into civil engineering. So to end this lecture, I thought on a lighter note, we'll see some things which are put up as jokes about us civil engineers. This is one diagram, if you can see. They started building a bridge. On one side they started building, another side they started building, and then when they reach the middle, they find that they're slightly off. So the civil engineering comes with a lot of responsibility. There's nothing like a small mistake. Whatever mistakes you do have a huge impact. Okay? So the responsibility of the civil engineer is very high. So that is why we are always very careful as a civil engineer, because if you make a mistake, it could have a huge impact and there's no getting back. So the impact is very strong. So here you have Superman trying to arm wrestle a civil engineer who doesn't look very strong, but he has so much in him that he has that impact which is possible. No? So civil engineers control so many things. If they do something, it has an impact on a lot of things. So the strength is inside, it's inherent to the civil engineer. This is a wedding procession. This is a wedding procession of two civil engineers getting married. And you can see here that they're standing on the excavator and followed by a procession with all their friends in the excavator. So the commitment is there. If you are a civil engineer, you are set all your life that to civil engineering, and you can't get out of the mode of civil engineering. Further, civil engineering is everywhere. Lot of you would have seen Harry Potter, right? This is a shot from The Prisoner of Azkaban, where you have Harry and his friend Ron flying with his car, and below them they see this very nice bridge. You might have noticed the car, but you may not have noticed the bridge, right? This is that bridge. This is a real bridge in Scotland, built more than 100 years back, 380 meters long. This is the Glenfinnan Viaduct, 21 spans, and constructed with mass concrete. No steel, just by the form. We'll talk later about architecture and structural analysis. Just the form was such that it needed no steel, and just the concrete could take all the loads and last for more than 100 years. So you can imagine this was the Hogwarts Express, and it needed this bridge to take Harry Potter and his friends to school. So civil engineering is everywhere. Civil engineering can also be a lot of fun. We think of civil engineering structures as massive structures which are always heavy. We can make light structures as well. Concrete, we think, is so heavy that it will sink, but these are boats, canoes made out of concrete. Concrete was used quite a lot to make ships in the early part of the previous century, because during the wars they did not have enough metal to make ships. So they made boats out of concrete, some are even still floating. But more recently, since the 70s, there is a competition which is called the concrete canoe competition, where a canoe, a small boat is made with concrete and people race with them and see who wins. So in India we started, IIT Madras was the first to start this competition in 2010, and this is one of our first canoes. So I am hoping that those of you who are at IIT Madras or want to come to IIT Madras will participate and make sure that you can make a nice canoe that doesn't sink and it will make you go fast over the water. So these type of things challenge you, because it's not normal to think of a concrete that will float. Concrete is supposed to be massive, that will hold a lot of weight. But here on the contrary, it has to be strong enough that it cannot collapse on water, it should not leak water, and it should be safe for people to travel. Okay? So the concrete and civil engineering, construction can be a lot of fun. So I'll stop with that. Thank you very much. The idea was in these two lectures to introduce civil engineering before we get to the different disciplines and talk about each of them in detail. So in the following lectures, we'll have different faculty members of IIT Madras talking about their specialization, so that you would know more about these specializations, what they concern, and see illustrative examples. Thank you.